Hello guys, this is CodeNCode and I'm going to start a new series in which we will learn the basic algorithms that are required for the beginners to have knowledge of to get started with competitive programming. And the first thing that I think that all the beginners should have knowledge of is binary search. So the first question that is actually necessary to answer is why you should actually learn binary search. So the very basic answer that you will get from any beginner is that it can be used to find an element in a sorted array in log n time. Well, that is very true, but that is not like even 1% what binary search can do. So let me show you real quick how beautiful binary search can be and how useful it can be in the competitive programming. So this, as you can see, is actually a snack down competition. This is competition, I guess. It was supposed to be a yearly competition, but didn't happen this year, so I'm guessing it would happen next year. So anyways, this is a qualifier round of Snackdown 2017, and the problem I want you guys to see is this: the problem snake eating. As you can see, there are 21,000 registered team in the qualifier round for snake down, but only 1,600 of them were able to solve this problem. You can argue that, okay, since this was qualifier round, so there was like okay, these many even if a team is able to solve two problems, they will be qualified for the second round or the next round. Yeah, that is very true, but that may be one of the reason why only the first two problems are having the highest number of submission, a higher number of accepted solution, while the snake eating is having the least. But look at the accuracy of this problem. This is having 38% accuracy, this is having 51% accuracy, this problem is having 12%, roughly 13% of accuracy, while this problem is having only 5.6% of accuracy. Okay, let's assume only 6% of accuracy, and this problem is literally a simple binary search problem. Not maybe not that simple, but literally, after you'll understand the binary search and the core of it, how binary search work, what is monotonic functions and all of that, once you would understand that, these kind of problem would be like these problems would feel too easy for you to solve. Believe me, if at that point of time I didn't have knowledge of binary search, that deep knowledge of binary search, I didn't have any clue that binary search can be used to solve these beautiful problems. I literally didn't have that knowledge that time. That is why I didn't solve this problem at that time. But now this is like literally the easiest problem using binary search I can solve. So we'll see how binary search can be used to solve so important problems, which are like the problem that are appearing in qualifier round and are the least solved problems. If we ignore these, let's look at this problem. The problem is factorial versus power. So there are t test cases where t can be as large as 10 to the power 5, and each time you will be given a, and you have to there are two functions, fn, which is n factorial, and gn, which is a raised to the power n, where a will be given in each test case. So you have to tell at which n factorial becomes greater than a raised to the power n. You can't even think to solve this problem using simple for loop or using brute force approach, because there are like 10 to the power 5 number of queries. So of course you can't solve it using brute force approach, and this problem again can be solved using binary search. In fact, just thinking instead of just thinking about this, just go and think how you'd solve or how you'd apply binary search to solve this problem, where you are given two functions, n factorial and a raised to the power n, where a would given in each test case. and you have to tell the least value of n for which the smallest value of n for which n factorial becomes strictly greater than a raised to the power n. So this is another problem that you can solve using binary search. This third problem, you see you are given an expression and also an integer set. So integer set in this test case, we are having three different values, 5, 7 and 10. So what we can do, these 6 variables that you see, each variable can have value, can have one of the values out of these 5, 7 or 10, and you have to tell how many different sextuples, that is 6 different ordered tuples exist there such that they follow this equation. So after putting those values of a, b, c, d, e and f, they should satisfy this equation. For this test case, answer is 10. That is, there are 10 different sextuples that satisfy this equation. Again, this problem can be solved using binary search. N, that is the size of the set, can be as large as 100. So again, this problem will be easily solved using binary search. We'll see all these problems, how we will solve each of these problems one by one. Aggressive chaos problem. Of course, if you would ask any experienced programmer, if someone asks what are good problems to practice for binary search, the first problem most likely they are going to suggest is aggressive chaos problem. I cannot explain this because I cannot explain this in this video because this is just an introductory video, so that would be like wasting time. So you can go ahead and read for yourself, especially this problem. After reading this problem, just try to think how you can apply binary search to solve this problem. That is the main question. We are not talking about the implementation, we are directly talking about how binary search can be used to solve this problem, the aggressive chaos problem. Now apart from that, you see binary search can be used to solve this problem. This is div2d problem, which is actually rated 1800. So you see, problem 1800 can be problem rated 1800 can be solved using binary search. And now this problem, this is a bit harder from the previous problem. This is D, but from educational round, and you know educational round is a little bit harder than a normal div2 round. Div2 only, not div1 div2 combined. And you see it is of course rated 1900. And again, this problem can be solved using binary search. So all of these problems which are much more difficult, and the problem that are not so easy to figure out how we can actually apply binary search to them, but those are actually solvable using binary search. So we will, in this lecture series, first we will start with binary search and we'll solve all of the problems that I've shown you in the slide, that these problems can be solved using binary search. In fact, after showing you some of the properties, the most important property a problem should have to be solved using binary search, that is monotonic property of a function. First we will start from there, and then after understanding the deep inside of binary search, the core idea why binary search works and how binary search works, you will be able to solve most of the problems by yourself. So this was all for this lecture. Thank you guys for watching, and till the next video drops, keep coding. Thank you.